Hi everyone, we're Meribot. I'm Noel Khan presenting with my teammates Michael, Arina, Shaunak, and Yatansh, and we are building a healthcare AI agent for patients. The problem we're trying to solve here is due to many people experiencing symptoms, but they're getting care at a very delayed rate. Healthcare systems are currently fragmented, slow, and difficult to navigate.
Here is a high-level ad hoc flow of how the system works. Users interact with the AI that then provide a range of services depending on what they need. These include diagnosing the symptom, triaging the patient, and scheduling the appropriate solution, such as a follow-up, an appointment, or escalating the matter. All of this is logged and added to the user's profile so that better recommendations can be provided in the future. Here is a more detailed ad hoc diagram where you can see the patient interacting with the agent and the agent facilitating a range of actions such as follow-ups, emergency escalation, recommending products, and booking specialist appointments depending on the symptoms of the user and what they require.
Here is a more detailed breakdown of all our functionalities. Here, the assistant supports conversations with context memory, multimodal inputs, clear decision making, such as actions, no actions, self-care, referrals, follow-ups, and emergency escalations with EMS with timers for the user. The action execution is done by adapters like book appointments, purchasing, notifying contacts, and scheduling follow-ups. The mandatory and optional capabilities are also marked so that the MVP is focused and it is extensible.
In our focus currently in this project, we will be looking at main key actors contributing to the system at hand, namely the patient, EMS, pharmacist, and doctor. All of these use cases have most of its interaction with the AI agent. Specifically, the get diagnosis use case is pretty much triggered when user has provided symptoms, so that this diagnosis case can then triage to self-help, identifying emergency, suggesting medication, and other use cases that's related to it. It's also up to the user to select the notification preferences, book that appointment that is suggested by the AI agent so that the historic session is preserved between AI agent and user.
In designing the package diagram, we use a layered pattern with hybrid approach of MBC to ensure scalability as well as maintaining a smooth user experience. First, we have the external users who will interact directly with the presentation layer, which is designed using MVC patterns for UI. And then all the information will be passed into the business layer, which is mainly containing the AI agents. It will make decisions based on the information and take actions accordingly. Then this business layer is able to import service layer where it contains mainly API calls, enable the system to actually make a booking or dial triple zeros for the patient. We then have a separate data layers to store user informations as well as AI knowledge base for fine-tuning the AI.
This class diagram is a design level architecture of our entire system. Here, the main classes are patient, chat session, and AI agent. A few key aspects in our structure are the abstract classes, such as healthcare staff, which are inherited by doctor, pharmacist, and EMT classes. According to this, the patient can't directly talk to the AI, but the interaction is managed by the chat session class, which is stored towards a user profile in their chat history class. Here is a runtime breakdown of one of the scenarios, particularly the emergency scenarios. This is a snapshot of the objects that are required for such a scenario. A patient is engaged in a chat session with an AI agent holding a current treatment plan, a pending reminder, and a possible scheduled appointment. This overview helps the stakeholders visualize the runtime relationships created by our flow.
Activity diagram. The follow-up activity requests an update compared to symptom history and prior advice. Then branch. In case of a critical condition, it escalates the case to EMS. If the condition becomes worse, the system books a doctor. If condition is improved, it closes the case and updates the record. The key is repeatable reassessment and not a one-off check-in. A clear way for us to visualize the interactions with the system can be represented by a sequence diagram. This request self-help sequence demonstrates how the UI, triad service, and notification subsystem coordinate with each other. This particular scenario is about getting the patient's self-help guidance and generating a treatment plan and how the notification action gets triggered. Machine diagram. Another scenario is visualized here, where we are managing the medical profile and record handling. This provides a high-level understanding of the interactions between the medical profile, the patient records, and treatment plan, and how the information and control flow between them. This design ensures that the records evolve and update consistently with every interaction.
For the architecture analysis and design of our application, we adopted the 4+1 viewpoint and choose to use all 4 viewpoints. For the logic view, which shows what the system does, for example, the core functionalities such as being able to triage patients or making a booking on behalf of the patient. This will be illustrated using use case diagrams, class diagrams, and object diagrams. Next will be the process view, which describes the runtime behavior and control flow of the system. We will use activity diagrams, sequence diagram, and state machine diagrams to illustrate that. And for the development view, which focuses on how the system is organized in code, we will use package diagram to illustrate the relationship of access and import between different packages. Finally, the physical view, which shows where the component runs, especially in hardware, we would use a deployment diagram to illustrate that.
All these diagrams up until now show how our system works, the logical relationships between components like the AI agent and patient. As an AI healthcare app, we've designed the deployment with key non-functional priorities in mind. Privacy and security through clear separation of layers and encrypted communication. Scalability with a containerized backend that scales independently. Reliability through modular services that avoid single points of failure. And extensibility by keeping third-party APIs like bookings, pharmacies, and emergency dialing coupled. Together, these design choices make the system not just functional, but ready for real-world healthcare deployment, ensuring that it's secure, scalable, and built to evolve. Now let's quickly talk about stage 2, our prototype. Our goal here is to build an end-to-end prototype guided by the class and deployment architecture to deliver a full stack, front-end, back-end, and database MVP. So keep an eye out.